G'day everyone, welcome to Methods Year 12 2020. We've just done our first test, which was on the syllabus points 3.1.1 to 3.1.9. Remembering all our work that we do is related to the syllabus, not to a textbook or anything like that. So these were the syllabus points we were working on. We had two sections to the test. The non-calc section is just here, and then we've got the calculator section to go through as well. So lots of points to pick up on, and I think most people will find they can easily pick up 3, 4, 5, even 6 marks just by 1 or 2 small alterations to what they're doing. So question number 1, 7 marks here. These two questions were really just, can you differentiate a reasonably simple one to differentiate? E to the f of x means derivative out front and multiply it through. Either were fine. If you tidied it up, great. If you didn't, not worry, because it just said differentiate. So leaving it in a unsimplified form is fine. The second one over there, now it's a little sneaky here. It's the sine of x times the second part. So that straight away is product rule. You've got two functions, sine of x and 3x minus 2 to the power of 4. And then in this one, you've got chain rule as well, don't you? So it's derivative of the first times the second, 1 mark. The first times the derivative of the second, which we've got to do the chain rule. I didn't even simplify it. You could bring this 12 to the front. Don't bother. It's worth 2 marks. There's your 2 marks. Leave it as that. Part C and Part D. Part C is a quotient rule question. So it's bottom times derivative of the top minus top times derivative of the bottom. 1 mark for the top line divided by the bottom line squared. 1 mark there. Okay. Fairly straightforward. If you could differentiate this one up here, the e to the x function, then you shouldn't have had any problem down here, because effectively you were kind of doing the same idea here in terms of what you were differentiating. This one, tan of x. Now, tan of x is not on your course as needing to differentiate, but we've only got to remember that it's sine over cos, and then you can do this the long-handed way if you want, or just remember that it's really just 1 over cos squared, because the top line becomes sine squared plus cos squared. Pretty easy marks there. If you did make your mistakes, it was probably around the product rule here. Most people did pretty well on the rest of it. Question number 2. Let's do 2a here at the start. Sine 3x. Now, a lot of people forgot that this is, again, it's a chain rule question. It's sine of u and u equals 3x. So because of that, the derivative of this needs to come out front. Now, if you already see that, and you can go, you know what, it's just 3 cos 3x, fine. But if you don't, write sine of u and u equals 3x, work your derivative, multiply it together, get your answer. But trust me, you won't have time in exams to do this in a long-handed way. You've got to just see that it's chain rule and know how to do it. Alright? If you did the whole y equals sine of u equals 3x, you're going to spend 3 minutes doing a 1 mark question. You haven't got time for that. Once we've got that, it's not so bad, because we just put this in, and neatly the 3x means this comes down to just pi on 6. Pi on 6 is like 30 degrees, so the cos of pi on 6 is root 3 on 2, and therefore I can tidy up and just get 3 root 3 over 2. However you wrote it up, doesn't really matter. These are essentially the same. I just kind of moved them closer together, really. But as long as you had the answer there, it didn't really matter. The one on the right-hand side here, same. People miss product rule. X is a function. E to the 4x squared is a function. Now, I'm kind of glad this has come up over and over in this test, because I remember 2 years ago, actually, this very classroom, I had a class in here, and a number of them just always missed the product rule. And I'd say, it's right there. Oh, I didn't see it. And it was first semester exam, they were still not seeing it. So I'm kind of glad that if you have been knocked off a couple of marks for not seeing the product rule, that's my reminder to you to say, look for the product rule, see it. read it 3 times. Say, hang on, where are the functions? There's a function, and there's a function. I must use product rule. So I'm glad that it's in here. Derivative of the first times the first times the derivative of the second, fine. You can tidy up if you want to, you didn't have to. Substitute x equals 2, we come down with 33e to the 16th. If you got 32e to the 16th, then you missed the product rule, because I think you missed out on this bit here. I think if you missed the product rule. So if you got anything but 33e to the 16th, I'm guessing your reason was product rule. Question number 4, or number 3. Now this one's a really good question. Again, product rule. So sorry if this is the 3rd time you've been hit by that one. You won't do it on the next one, I guarantee it. Now this question is really good because it's making you recognise that E is just a number. A few people were trying to kind of solve for what E is. No, E's 2.718. We know what E is, but let's just use E. Just like we use pi. I know that pi is 3.14, but I can answer area questions in terms of pi. So same thing. Don't try and solve for E. That's not the variable. The variables are y and x. E is just a number. So I get this, and I do the derivative of it. Right? Here's the derivative. I substitute in x equals 2, and I get the gradient being 4e. Now what does a gradient of 4e look like? Well, e's 2.7. Let's round it to 3 for now. 3 times 4 is 12. So the gradient is quite steep, positive gradient of 12, or close to. So that's what it actually looks like, but who cares what it looks like? We don't care, it's 4e. We're done with that. So then once we've got that, I can then figure out what the value of y is when x equals 2. So take the 2 into the original equation, and I've got a y value of 4e. So I've got a gradient, and I've got a point at where this is happening. So that means when I go over here, and I use y equals mx plus c, I've got a y value, that was down here. I've got a gradient, that was right here. The x value, it's all happening at x equals 2. The only thing I don't know is c. Rearrange and I've got minus 4e. Throw it all together, there we go. Y equals 4ex minus 4e. Alright? Now, as I say, easy to get lost on the way. Easy to miss that you don't need to solve for e. E is just a number. But a good question. This is your methods type question. This is the one where you've got to understand and see what's happening. Okay? Let's keep tracking along. If you've got questions, we'll do them at the end. We'll do them at the end. Come on, go to my next page. There we go. Right, here we go. Second section. Same details, 34 marks, 35 minutes. We're all good to go. Let's scroll on in. So the first one's a population one. Okay? You remember this formula, P equals P0 e to the kt. That's our exponential growth and decay formula. If k is a positive number, then we're talking exponential growth. If k is a negative number, we're talking decay. Okay? If k were to be 0, then that whole part would drop out, and then it would be a constant rather than growth or decay. But that we don't do questions like that, they're too easy. Determine the values of P0 and K. Well, it told me right here that initially there were 1300. That's my initial value, that's where we start. P0, 1300. Then it says about K. Well, knowing that 1300 is P0, and knowing that 2900 were there 4 weeks later, I just put that into my equation, solve, and I get K. Now, big question mark here. People asked me in the test and said, do I have to write to a whole number of decimal places? And I went, no, 2 decimal places is fine. And it is. This is also a fine answer, but if you've written 0.20, fine, no problems at all. But in the following questions, you must use the entire number. So you round to give an answer, yes, but save that entire number in your calculator for every following calculation. Otherwise your calculations are incorrect on the following ones. This number must be used all the way through. All the way through. Okay? Now, this question was 3 marks. So if you'd just written 0.2 and 1300, I didn't have to give you the marks. Because 3 marks says you need some working. Show me what you're doing. Even if you'd just written this is fine. This tells me I know the value is that. That's the initial value I'm putting 4 in. It tells me what I need to see. Don't just write answers in a question that's worth 3 or more marks. Okay? You run the risk of only getting the mark for the answer. Okay? In this case, you would have got 2, 1 here and 1 there. If you'd only written the answers, you wouldn't have got the working mark to show what you were doing. I think I was pretty generous there. I think I was generous. Part B says, what will the ant population be after 10 weeks? As I say, use the full number. You don't have to write it there. You write 0.20, that's fine. But use the full number because otherwise your answer here will be incorrect.
So
okay?
on the, because you're talking about ants, would you like us to round to your own number?
Ah, you're thinking my language. Now, can you show me 0.29 of an ant? Is it alive or is it dead?
Dead.
It's dead. Right? It's only got one section of its body and one leg. Right? So if you've got a number like that, round it down. Because to me, 0.29 of an ant is a dead ant. Even if that was 0.85. You don't have a full ant, do you? I would always round it down. Now, in practice, with these sort of questions, usually, whether you answered 9662 or 9663, you're probably going to get the mark anyway.
So,
okay? Another way, yeah, a little description to say, something like, you know, rounded down as 0.29 of an ant is a dead ant. You know, something like that will be good. But remember, it's only worth 1 mark. It's only 1 mark. So basically, if you can show me that you know what you're doing, you're going to get the mark. The other way of writing it is you could say something like approximately 9,660 ants, which you wouldn't be incorrect. You wouldn't be incorrect. And remember, it's a prediction of the future anyway, so you may well be correct. Okay? Shh, shh, shh. Wait, shh. So you can round if you want. Now, here's the other thing. If this number came out to